Alright guys, in this video we're going to talk about the answers to the Chapter 6 homework problems. For Chapter 6 I'm going to be going over 4 problems. The first is from Facts and Tools, problem number 6. And then in Thinking and Problem Solving I will be talking about problems 6, 7, and 8. So let's begin with Facts and Tools. Problem 6. Suppose that Maria is willing to pay $40 for a haircut and her stylist Juan is willing to accept as little as $25 for the haircut. Let's put that information on the board. So we've got willingness to pay and willingness to accept, $40 and $25. Part A asks us what possible prices for the haircut would be beneficial to both Maria and Juan. How much total surplus would be generated by this haircut? All right, well, the range of prices that would be acceptable to both of them would be anything between $25 and $40. The lowest price that he's willing to accept, the highest price that she's willing to pay. Any price that fell out of that range would result in no haircut taking place. All right, no bargain being struck. Now, how much total surplus would there be? Well, that's going to be the difference between the lowest price that Juan would accept and the highest price that Maria would be willing to pay. So the total available surplus, or we'll call it the TS, for total surplus would be $40 minus $25, which is equal to $15. So that's the amount of surplus that is available. It's going to be split between them depending on the price that they end up agreeing to. So in the case that they agreed to a price of $40, all $15 of surplus would go to Juan because Maria would be paying the highest price she's willing to pay. If they agreed on a price of $25, then all of the available gains from trade would go to Maria, because his surplus would be zero. He'd be getting paid exactly the lowest price that he would be willing to accept. And then, of course, if they met exactly in the middle at what would that be? Say $32.50. Then they would be splitting this surplus evenly between the two of them. All right, Part B. Part B asks, if the state where Maria and Juan live instituted a tax on services that included a $5 per haircut tax on stylists and barbers, what happens to the range of haircut prices that benefit both Maria and Juan? Will the haircut still happen? And will this tax alter the total economic benefit of this haircut? Okay, well, if they impose a $5 tax on stylists and barbers, that's going to increase the lowest price that Juan would be willing to accept. This $25 represents just his costs of his time and of the materials he's going to use. But when the government is also collecting a $5 tax from him every time he cuts somebody's hair, well, he's got to factor that into the price, the lowest price he would be willing to accept as well. So this is going to change from $25 to 25 plus 5. I'm going to write that plus 5 off to the side just so that we recognize that as a tax. Now the new price range that would guarantee a transaction would be anything between $30, that's the lowest price that Juan would now accept, and $40, the highest price that Maria would be willing to pay. Is this transaction going to still happen? Will the haircut still happen? Yes, we expect it to, because between the two of them, there's still $10 of surplus that is available to split between the two of them. Last part of the question is, will this tax alter the total economic benefit of the haircut? It's not going to alter the total economic benefit of the haircut, but it will change the economic benefit of the haircut available to Juan and Maria. Okay, because there's still the $15 of surplus between the lowest price he would accept without the tax and the highest price she would pay. But once that $5 tax has been paid, that's got to be subtracted from the amount of surplus that is available to them. So between the two of them, there is $10 of surplus. However, that $5 that the government is collecting doesn't just disappear. That would still be going to the government. So over here you've got Juan and Maria. They would be getting a total of $10 of surplus or of economic benefit. $5 would go to the government, and then the sum of those is $15, the same as it was in part A of the problem. Part C, what if instead the tax was $20? All right, well, if the tax is $20, now when you add that $20 to the lowest price that Juan would have been willing to accept without the tax, that adds up to $45. $45 is more than the $40 that Maria is willing to pay. And so in this case, there would no longer be any economic transaction, right? They cannot agree on a price that would be acceptable to both of them. That means the total available surplus, or the total surplus that is captured, is going to be $0 because there will be no trade. And also because there is no trade, there's no tax collected by the government on that non-existent transaction. And so it does affect the total economic value that's available. All right, I'm going to clean up the board and then we'll talk about thinking and problem solving, problem 6. All right, with thinking and problem solving, problem 6, you're given a graph that looks pretty much like this, except that that triangle is highlighted in yellow. And the problem says the following. Consider the following diagram of a tax. The triangular area representing the deadweight loss is highlighted, and its dimensions are labeled base and height. Recall that the formula for the area of a triangle is 1/2 times the base times the height. All right. Part A. In order to calculate the deadweight loss of a tax, you don't need to know the entire demand and supply diagram. You just need to know two numbers, the base and the height of the deadweight loss triangle. What is the real life meaning of the base, and what about the height? Okay, well, the real life meaning of this base is the size of the tax per unit, how much money is being collected by the government for every trade that occurs. Okay, and that magnitude gives you the tax wedge that you put onto your graph. Remember, wherever this tax wedge hits the demand curve, that sets the price for the buyers. Wherever it hits the supply curve, that sets the price for the sellers. The difference between those two prices is the tax per unit. Okay, so the base of this triangle represents the magnitude or the size of the tax. And then what about the height? The height represents the reduction in transactions because of the tax. So note that if this market were in equilibrium, you would get this quantity of units, QE. However, once the tax is imposed, the price to the buyers and the price to is too high to the buyers to be worth purchasing these extra units, and it's too low to the sellers to produce those extra units. And so with the tax, you get a reduced quantity of transactions. We'll call that QT, the quantity once the tax has been imposed. Okay? The height of this triangle is equal to the difference between the number of units that would trade in equilibrium and the number of units that are actually trading now that we have the tax. All right, let's see. Part B asks the following. Can you turn your answers to Part A into general rules about the deadweight loss associated with taxes? Try phrasing it like this, but replacing the part in brackets. The larger the base or height, the more deadweight loss is generated by a given tax. All right, so converting these terms into what they actually are in economics, you could change that phrase to be the following. The larger the tax per unit imposed on a good, the more deadweight loss is generated by a tax. Okay, and that makes sense because the taller this tax wedge is, the farther away from equilibrium you're going to be, and so the bigger this deadweight loss triangle is. If you cut the tax to a smaller amount, you could say fit it to there, and then you'd have a smaller deadweight loss triangle. And then with regards to the height, the larger the number of discouraged transactions, or the larger the number of transactions that no longer happen because of the tax, the larger the deadweight loss. Okay, and that's also true. Is the more units you discourage people from buying, the taller this triangle is going to be, and so the larger the area is going to be captured by that deadweight loss triangle. Part C, holding the base constant, the height, and thus the deadweight loss would get larger if the demand curve or the supply curve were more what? Fill in the blank. The answer there is elastic. So I'm going to erase this and put up a couple of other graphs to show you the answer to part C. All right, so now I've got two graphs here with supply and demand. In both of them, supply is perfectly elastic. It's just a flat line. I'm using perfectly elastic supply just to make sure that elasticity of supply is the same in these two graphs. So we're going to hold that constant, and then we're going to look at a case where we have a more inelastic demand curve and a case where we have a more elastic demand curve. And what we'll see is that the deadweight loss is going to be larger here, where demand is more elastic. Okay. This reasoning also holds with the supply curve. You could make it more elastic or more inelastic, but to keep things simple, I'm going to just focus on demand. Okay, so let's start with a given tax wedge. I'm going to pick a point right here. Okay, there is the tax wedge, and the deadweight loss that results is this area right here. Now, let's draw the same tax wedge on this graph. So take that height and find the point on this graph where supply and demand are that far apart. Okay, there is our tax wedge. That gives us a deadweight loss like so. Okay, now just eyeballing these two, it's perfectly obvious that this is the smaller deadweight loss than that. But also you can tell geometrically that, even if you couldn't look at them, that this is going to be a larger deadweight loss than that one is. Why is that the case? Well, they both have the same base, right? Because we're using the same tax wedge in both of these graphs. But here, where demand is more elastic, the height of this, or the length of this this deadweight loss triangle, must be longer or larger than the height or the length of this deadweight loss triangle. Okay, and so you can think of this as, remember, the tax wedge, the closer you can get it to the old equilibrium, the less distortion there is in the market, the less deadweight loss there's going to be. Well, the flatter your demand curve and supply curve, the less distance there is between them. Right, so that the earlier that tax wedge is going to get stuck between them, and it's going to be farther away from equilibrium. If demand here was perfectly inelastic, well then you could slide that tax wedge all the way to equilibrium. It wouldn't change the number of transactions in the market. Okay, but this really elastic demand curve, you're discouraging a lot of the transactions. Right, so part D asks, without having a diagram as a reference, can you answer the preceding questions for a subsidy? Part A was asking about the meaning of the base and the height of a deadweight loss triangle. Well, for the base, when you're talking about a subsidy, the base represents the size of the subsidy per unit. How much money per unit is the government paying you to engage in the transaction? And the height of that deadweight loss triangle is going to be the number of extra transactions are encouraged by the subsidy, as opposed to the number of transactions that are discouraged by the tax. In Part B, can you turn your answers into Part A into general rules about the deadweight loss associated now with subsidies? Well, it would be the larger the subsidy per unit, the more deadweight loss is generated by a given subsidy, and the larger the number of extra transactions occur in the market, the more deadweight loss is generated by the subsidy. And then Part C, holding the base constant, the height and thus the deadweight loss would get larger if the demand curve or the supply curve were more. Once again, it's going to be elastic, because with subsidy wedge, you're just bringing it in from the other side of equilibrium, right? So if I took this and made it a subsidy wedge, I could still get pretty close to the equilibrium where this demand curve is inelastic. Whereas over here, I'm going to be farther away from equilibrium with the subsidy wedge because this demand curve is so elastic. All right, so you get the same reasoning whether it's a tax or a subsidy that you're talking about. All right, I'm going to erase this and then we'll talk about problem 7. All right, just to set the stage for the answer to this problem, let me direct your attention to the graph that I've got on the left-hand side of this board. Note that QE refers to the quantity of units that would be traded in equilibrium. QT refers to the number of units that are trading once the tax is imposed. So in this table over here, QT is just saying how many units are still traded in the market. QE minus QT, that's the number of transactions that are no longer happening. It's the number of reductions in trades. Okay, so with that, let's read through the language of the problem. Problem 7, suppose your state government has decided to tax donuts. Currently in your state, 300,000 donuts are sold every day. 3 possible taxes are being considered by lawmakers. A 20-cent per donut tax, which would decrease donut sales by 50,000 per day. A 25-cent per donut tax, which would decrease donut sales by 100,000 per day. And a 50-cent tax, which would decrease donut sales by 150,000 donuts per day. Part A, calculate the amount of tax revenue generated by each tax and the deadweight loss caused by each tax. Okay, well the tax revenue is just this area on the graph right here, which is the tax per unit times QT, times the quantity of units traded. And then the deadweight loss is the tax per unit times QE minus QT, right, the number of reduced trades, divided by 2 because we're calculating the area of a triangle. So we've already got the tax per unit, now I need to fill in QT and QE minus QT. Remember that, well, they just straight up give us the number of reductions here. They tell us that the 20-cent per donut tax would reduce donut sales by 50,000 per day. And the 25-cent would reduce by 100,000 per day. And the 50-cent would reduce by 150,000 per day. And then you're also told at the beginning there, in your state, 300,000 donuts are sold every day without a tax. So QT would be 300,000 minus 50,000 is 250,000. And in this case, it would be 300,000 minus 100,000 is 200,000. And in the final case, it would be 300,000 minus 150,000 is 150,000. So now we're going to calculate the tax revenue and the deadweight loss. Tax revenue is just going to be the tax times the quantity of transactions. 20 cents times 250,000 donuts is $50,000. 25 cents times 200,000 donuts is also $50,000. And 50 cents times 150,000 donuts is $75,000. Okay. All right, now the deadweight loss is going to be this number, the tax, times this number, the reductions in trades, divided by 2. 20 cents times 50,000 is 10,000, divided by 2 gives us $5,000 in deadweight loss. 25 cents times 100,000 units is 25,000, divided by 2 gives us $12,500 in deadweight loss. And finally, 50 cents times 150,000 reduced units is 75,000. 75,000 divided by 2 is $37,500 in deadweight loss. Okay, so that's the answer to these two columns, gives us the answer to part A. Part B. If the goal of your state government is simply to raise the most tax revenue, which tax is preferable? Well, it's going to be the 50-cent per unit tax, because the 50-cent per unit tax generates $75,000 in tax revenue, which is more than the $50,000 in tax revenue that the other two taxes at 20 and 25 cents would get you. Part C. If the goal of your state government is to raise tax revenue in the most efficient manner, meaning with the least deadweight loss per dollar of revenue, then which tax is preferable? So now that question is asking us to bring in another column. That last column, I'm going to make space here for that final column. And here we are looking at the deadweight loss divided by the tax revenue. Okay, or the deadweight loss per dollar of tax revenue raised. Okay, and so all you're doing for this column is taking your deadweight loss, dividing it by the number that's in the tax revenue column. And so what do we have here? $5,000 divided by $50,000 gives us 10 cents. Okay, there's a 10-cent deadweight loss for every $1 of tax revenue that is raised with a tax of 20 cents per donut. Here we've got 12,500 divided by 50,000. That's going to be 25 cents, because this is 1/4 if you divide 12 and a half by 50. So there is a 25-cent deadweight loss for every $1 of tax revenue raised by the 25-cent per donut tax. Finally, 37,500 divided by 75,000 gives us 50 cents. There's a 50-cent deadweight loss for every dollar of tax revenue that we're raising. That tells us that the most efficient tax is the smallest one here, 20 cents per donut. Only gives up 10 cents per dollar in tax revenue raised versus 50 cents. So now let's move on to part D. What other goal might your state government have when creating this kind of tax besides raising tax revenue? Well, the obvious answer is that donuts have an impact on the health of the people in the state, right? The state might be interested in fighting obesity, for example, and they might tax something like donuts to make them more expensive to discourage people from consuming them, just like we tax cigarettes and alcohol in part to reduce people's consumption of those goods. All right, let's move on to problem 8. Once again, I'm going to clear the board so that I have room. Okay, problem 8. How is it that a tax creates a deadweight loss by decreasing quantity, but a subsidy creates a deadweight loss by increasing quantity? Well, you can get at the answer to that by looking at just your basic supply and demand graph. Remember that a deadweight loss is a destruction or a loss of value, of surplus. Now, all of the trades to the left of equilibrium, let me mark that point here. Remember that the demand curve tells us the most that a person would be willing to pay for each unit. The supply curve tells us the cost of producing that unit, or the lowest price that a seller would be willing to sell the unit for. As long as buyers would be willing to pay more than it costs the seller to produce, there is positive surplus available. There are gains from trade available on that transaction. So every trade to the left of equilibrium creates an opportunity there. And you would want all of these transactions to happen in order to capture all of the available gains from trade. Everything to the right of equilibrium, we don't want any of those trades to happen, because if any of these trades happen, the cost of producing the unit is greater than the value that the consumer gets out of the unit. And so this represents loss of surplus. It basically, you're taking goods where the cost of the resources is greater than the value of what you turn the good into. So you're wasting resources if you make any of these transactions happen. Okay? Well, now let's think about, let me back up for a second. What that essentially tells you is you want to be here at equilibrium. This is the best place to be. And being too short, right, not getting enough transactions is going to reduce the amount of gains from trade, because there's going to be some transactions that could have happened and would have been beneficial, but they didn't happen because of the tax. On the other hand, if you have, so let's call that QT, QT gives up these transactions due to the tax. On the other hand, if you have a subsidy, and you create a subsidy wedge like so, you end up with this quantity, QS. Now, too many transactions is not better than too few transactions. QE is exactly the right number of transactions. If you have a subsidy, that creates a deadweight loss by destroying the value of some of your resources, by wasting resources, turning them into something that they are less valuable than individually. Okay, whereas a tax, that prevents you from capturing some of the value that you could have had. So those are the answers to the Chapter 6 problems. The next video, I'm going to talk about the Chapter 8 problems.